Hi, this is Dr. Remenacker. In this video, we are going to continue looking at shortcuts or easier ways to compute derivatives other than applying the difference quotient each time. If you'll recall, in a previous video, we learned about the power rule. And the idea of the power rule over here to the right is if you have something like x to the fifth, the derivative is going to be 5x to the fourth, where you just decrease the power by 1 on the exponent, and the original exponent becomes the coefficient. Okay, so there is a brief recap of the power rule. Now hold on to that because we will continue to use that throughout the rest of the semester and next semester. We're going to learn two more rules for taking derivatives today. The first of these is called the product rule. The product rule is called the product rule because it is a function that involves multiplying two different functions together. For example, suppose we have something like y is equal to 3x squared plus 6x minus 7 times 8x cubed plus 17x. On the right-hand side, we have two separate functions, and they are being multiplied together. What's going to wind up happening is when we encounter situations like this, instead of foiling things out, combining like terms, and then applying the power rule, we're going to call one of these functions f and the other one g, just like you see over here to the left in the equation cap f. In other words, capital F is equal to f of x times g of x. What the product rule says is if you have a situation where you have two separate functions multiplied together, you can compute the derivative of the entire function by computing the derivative of the first part times the second. Notice we're not taking the derivative of the second part here, just the first part. So we do f prime g plus, real important to pay attention to the plus, then we do f g prime. Let's take a look at a couple of examples of how this works, and then we'll come back to this proof. Okay, so we have a proof here to show why it works. Let's first take a look at how it works. Okay, so let's say we have a situation here, or erase a couple of these things, make it a little easier for you to focus on. We've got this function, y is equal to 3x squared plus 6x minus 7 times 4x plus 3. One option would be to take the 4x and distribute it over all three, then the 3 and distribute it over all three, and it's starting to look like a bunch of fireworks here. However, there is an easier way to handle this, and that easier way is to say this first part we're going to define as f, and the second part in the product we're going to define as g. Okay, so we have our two pieces defined. Then, as I move down to the next line in computing the derivative, just to help me remember what I'm doing, I'm going to put the formula for the derivative, that's all of this stuff, up above. So it's going to be f prime g plus f g prime. It's actually a good move because it allows you to keep in mind where you are in the process. F prime says to come up to the 3x squared plus 6x minus 7 and compute its derivative. That's just a bunch of power rules. The derivative of 3x squared is 6x, the derivative of 6x is 6, and the derivative of negative 7, a constant, is 0. The derivative of any constant is always 0. Now be careful. Here's where people make mistakes. What we're going to then do is we're going to multiply it by g, not g prime. You don't just take the derivative of both chunks and write them down and ta-da, you're done. It's not quite that easy. So we copy down the second factor, 4x plus 3, plus, then the second part of the rule for product says we're going to do f. Well, f is just copying down the 3x squared plus 6x minus 7 times the derivative of g. Well, the derivative of this 4x plus 3 is just 4. At this point, it's done. I'm not going to ask you to multiply this stuff out, combine like terms, simplify, and all that kind of stuff. We're just going to leave it like it is. We can work with it like it is for a good chunk of time. At some point, we're going to have to do some simplification, but for right now, just computing the derivatives is fine. Let's take a look at another example. Here in the middle of the screen, we have k of x is equal to 2x to the fourth plus 5x squared minus 7x times 11x minus pi. Okay, so we have a first piece that we're going to multiply times a second piece. First piece we'll label as f, the second piece we'll label as g. I'm going to write down the rule that we're going to follow, f prime g plus fg prime, and then just follow the rule. It's kind of like having a recipe. First thing I'm going to do, it says take the derivative of f. Well, that's just 2x to the fourth. The derivative is going to be 8x cubed, plus the derivative of 5x squared is going to be 10x, minus the derivative of 7x is going to be 7. So here we have the derivative of f. Multiplied times that is just whatever g is equal to, the 11x minus pi. Be very careful to include the plus sign. That's easy to forget when you're in all this computing of derivatives. Then the second half of the rule says that you just copy down what f is, 2x to the fourth plus 5x squared minus 7x times the derivative of g. Well, the derivative of this second factor is just going to be 11. The derivative of 11x is 11. The derivative of pi is 0. Pi is a constant. And there you have it. At this point, this one is done. That's all there is to it. Let's go into a third example here. Pause your computer, work this out by hand, and see what you come up with. Okay, so hopefully you actually paused the computer and tried working this out. In order to compute the derivative, what I'm first going to do is I'm going to rewrite the square root of t as t to the 1/2 plus 7 times, we have 3t minus 4 times t to the 1/2 plus 18. So what I'm going to do is I'm going to rewrite this so that I now have rational exponents. Instead of a bunch of radical signs, I have my f and g. So there they go. All right, the formula was already written down. It's f prime g times fg prime. The derivative of f, let's see, the derivative of t to the 1/2, I'm going to wind up with a 1/2 t to the 1/2 minus 1 is a negative 1/2, plus the derivative of 7 is 0. So that's just going to be 1/2 t to the negative 1/2 plus 0, just going to leave that alone, times the g. Just going to copy down g, which is going to be 3t minus 4t to the 1/2 plus 18. So there's g copied down. The next thing I'm going to do is I'm going to remember to put in the plus sign. Plus. Now I'm going to copy down f. Well, that's t to the 1/2. Notice I'm not taking the derivative this time. Plus 7. However, for g, I need to take its derivative. So what I'm going to wind up doing is I'm going to look back up here and take the derivative of this term by term. The derivative of 3t is 3 minus. For this middle term, I'm going to have 4 times 1/2 is 2t. Now I have a 1/2 minus 1, which is going to be a negative 1/2, plus the derivative of 18 is 0. Well, plus 0 isn't all that needful, so I'm just going to leave that out. And right there is the solution. That's it. Don't try to combine terms. Don't try to multiply things out. Leave it alone. If you mess with it, you're just going to break it. So just leave it alone. Okay, here's another example. Go ahead, pause the video, and work this one out. All right, hopefully you paused the video. As with the previous problem, in some cases it's better to rewrite things so that you have exponents that are easy to deal with. 3 over x squared is the same thing as 3 times x to the negative 2. Then we have plus 7x minus, I'm not going to concern myself with rewriting this square root of 15 because square root of 15 is a constant. And when it's time to take the derivative of it, the derivative is always just going to be 0. Don't really need to do anything to the second factor, so I'll just leave this as 4x squared plus 17x. I'm going to be careful to label my pieces as f and g. That way I won't get lost part of the way through. All right, I have the formula written down, f prime g plus f g prime. I'm going to do it one piece at a time. F prime says to take the derivative of that piece right there. That's going to be a minus 6x to the negative 3. Well, wait a minute, where did negative 3 come from? Well, we have x to the negative 2. We subtract 1. Negative 2 minus 1 is negative 3. Moving on to the second term, the derivative of 7x is going to be 7. And the derivative of the square root of 15, remember, square root of 15 is a constant, that's going to be 0. So I can put down plus 0 or just leave it alone. Then I'm going to write down what g is. That's this 4x squared plus 17x. Be careful, we need to include this plus sign. Then I'm going to copy down what f is. That's his 3x to the negative 2 plus 7x minus the square root of 15. Then I'm going to take the derivative of g. The derivative of 4x squared is 8x plus the derivative of 17x is 17. And that one's done. People often seem to get the hang of product rule, and once they do, they're very comfortable with it and become confident of what they're doing with it fairly quickly. Okay, continue practicing these in the homework. We're moving on to the second rule that we're going to learn in this section. The second rule is the quotient rule. Well, yeah, if you multiply two things together, product rule, the inverse of multiplying is dividing, so I guess we need to look at the quotient rule now. For the quotient rule, as before, f and g both have to be differentiable. You can't take the derivative of them if they aren't differentiable. And really important, g cannot be 0. This is important because if g is in the denominator and it's 0, you have an undefined function. Okay, so what we're going to do is we're going to start out with some function. There it is. It'll be a function on the top divided by a function in the denominator. When we go to compute the derivative of it, it works out to be, yeah, it's not quite as easy as the product rule, but there it is. Okay, so let's apply this. First thing I'm going to do is, in this example here, we have this 3x squared plus square root 5 divided by x squared minus 2x. The numerator is my f. The denominator is the g. At the very top of the screen is the quotient rule. It's f prime g minus f g prime, which I've already written down over here as an outline of what my numerator is going to look like. First thing I'm going to do is f prime. That means compute the derivative of this. Well, that's 6x. There it is. Notice I do not take the derivative of the denominator. It just says copy down what g is. Well, g is this x squared minus 2x. So I've got that copied down. Be really careful. This is not the product rule. This is the quotient rule. You do not add the two terms. You subtract them. Now we're going to do f. Well, that's what was in the numerator, the 3x squared plus the square root of 5 times g prime. G prime is this, or g is this x squared minus 2x. The derivative of x squared is 2x. The derivative of 2x is going to be the minus 2. Then in the denominator, look what we have in the denominator. Notice it is not g prime, not g prime. It's just g squared. So I'm just going to copy down the x squared minus 2x, put it in parentheses, squared it, and ta-da, there it is. It's all done. At this point, do not bother trying to simplify it, just write it down. People try to get fancy and do a bunch of simplification. They get lost in the algebra and they wind up losing points on an answer that was completely right and worth full credit two lines earlier. Take a look at this second one here, now at the top of the screen. We have this 3x to the fourth plus 2x divided by x cubed minus 1. Well, okay, I'm going to label the stuff on the top as f. The stuff in the denominator is g. I've already laid out the rule. It's f prime g minus f prime g minus fg prime. There we go. Okay, so first thing I'm going to do is I'm going to take the derivative of the numerator, 12x cubed plus 2, times g. Well, g just means copy down this x cubed minus 1, put it in there. So those two things are multiplied together. Very careful to have a minus sign, not a plus sign. I know I've said this a bunch of times, but it's a very common mistake. And I'm trying to say it enough that you won't make that mistake. Okay, for the second part in the numerator, we have f. Well, that's just no derivatives or anything. Copy it down the way it is. 3x to the fourth plus 2x. G prime. Well, that means take the derivative of that, which is going to be 3x squared. What happens to the 1? Well, remember, if you take the derivative of a constant, it's 0. So it disappears. Then in the denominator, all you need to do is copy down what g is, the x cubed minus 1 in this case, put brackets around it or parentheses, and square it. That's it. Okay, with having worked through a couple of them, why don't you pause the video and work through the derivative of this one. Hopefully you've actually worked through the derivative of this. It'll make a little more sense as we go through. Remember, the polynomial in the numerator is f. The polynomial in the denominator is g. And we want our numerator to be f prime g minus f g prime. Okay, so I'm going to put all that in the numerator. And the denominator is just whatever g is squared. So I've already got the denominator done on this one. Now, in the numerator, I'm going to compute the derivative, going back to the original function, of what was in the numerator of the original function. Well, that's going to be 14q plus 11. Then I'll go multiply it by whatever's in the denominator. That's just q. Minus. Then I'm going to copy down what's in the numerator, the 7q squared plus 11q times, now it says the derivative of g. Well, the derivative of q is just 1. Fine, I'll put that in there. Or, if you want, you can leave the 1 out, because 1 times that second term is just going to be the second term, so you're still going to wind up with just that. At this point, it's done. Leave it alone. As we move further into the course, you will wind up needing to distribute and combine like terms in the numerator and hopefully factor something out that'll cancel with the denominator. But for right now, getting the derivative by itself is sufficient. In business and economics, 3 very important ideas are average cost, average revenue, and average profit. To compute the average, you divide the total by how many you have. For example, let's say you go into Aldi's or Kroger's or something or other, and you buy a 12 pack of pop, and you pay, oh, let's say $4.99 for its on sale. The question could be then, what is the price per can? Now, a lot of people will say, well, gosh, what's the price per can? And then say, well, I have no idea how to get the formula for that. But in saying price per can, you've actually said the formula. It's the price divided by cans. Oh, this would be the $4.99 divided by 12. And if you take the $4.99 divided by the 12, it works out to be 0.42. We'll round it off to the hundredth since numbers in US currency stop in the hundredths spot. If you buy this 12 pack for $4.99, it's an average of 42 cents per can. When you compute average cost, average revenue, or average profit, you're looking at the cost, revenue, or profit per unit produced or sold. Where understanding the price per unit, the revenue per unit, or profit per unit comes into play is in situations like the following. Okay, we're going to look at a greenhouse where they're raising some roses. Before that, though, let's just think about it in general. Suppose that you're working for a company. At the end of the week, your manager says, well, gosh, how much money did you spend this week? He said, well, we spent $1.2 million. Spending $1.2 million could be a great deal, or it could have been a really huge waste of money. It depends on how many products are produced. If you only made one wheelbarrow and it cost you $1.2 million, that's a problem. If, on the other hand, you made two aircraft, that's probably not a bad deal, unless it's something really small. Let's say two Lear jets. You were able to manufacture two Lear jets for $1.2 million. Now that sounds reasonable. So just knowing what the cost, the revenue, or the profit is does not really give you a full understanding of the situation. You need to know the cost, revenue, or profit per unit. Okay, so to get these, as listed at the top of the screen, you just divide whatever the cost is by Q, the revenue by Q, or the profit by Q, where Q is a variable, just like X, and Q represents how many units. It's the quantity. Okay, so with this in mind, let's take a look at what's going on here. For this company, it costs 200 plus 100 times Q to the 1/4 power to produce Q 100 roses. Watch the units here. If Q winds up being 2, that is 200 roses. Okay, so we have to be careful. Then the revenue off of these roses is going to be 120 plus 90 square root of Q. Part A asks you to compute C bar of Q, R bar of Q, and P bar of Q. Well, what's that little bar above each of those mean? What that bar means is the average. Okay, it's a mathematical way, quick notation to say average profit, average revenue, or average cost. Well, C bar of Q is going to be pretty straightforward. We're just going to take whatever the cost is, plus this 100, and we have the 4th root of Q, and you just take and divide the whole thing by Q. That's all there is to getting average cost. Average revenue, play the same game. All we're going to do is we're going to take our revenue function, it's 120, plus 90 times the square root of Q, and you divide by Q, and you're done. For the profit function, Okay, I'm eventually going for the average profit, but for right now, I'm going to do profit, which is revenue, 120 plus 90 square root of Q, minus the cost, 200 plus 100 times the fourth root of Q. Okay, so we have 120 minus 200. That's going to be a negative 80 plus 90 times the square root of Q. Then we're going to have minus 100 times the fourth root of Q. Now that is not the average profit. That is our profit function. To get the average profit, what I'm going to do is I'm going to take this equation to the far right. I'm going to rewrite this a little bit. I'm going to write this as 90 square root of Q minus 100, the fourth root of Q minus 80. There's the profit function. To make it an average profit, I just divide it by Q. And that's it. Okay, now for any of these three that we've just figured out here, notice it asks us not only to get the average cost, average revenue, and average profit function, but it asks us to compute the average cost at 250 roses. Now you got to be really careful here because Q is in hundreds of roses. So 2 means 200 roses. 3 means 300 roses. If we're going to do 250 roses, that's going to be 2.5. So this is going to be 200 plus 100. Then I'm going to have this 2.5 to the 1/4 power, all divided by 2.5. Not going to mess with plugging that into the calculator and figuring it out, but there is how you would compute the average cost. Now, what the average cost is going to tell us is the price per rose when we're raising 250 rose bushes. So this is the price for one rose bush, our cost when we're making 250 or growing 250 of them at a time. The average revenue, once again, we got to be careful because Q is in hundreds. So we're going to use 2.5 is going to be 120 plus 90 times the square root of 2.5 divided by 2.5. This, when simplified, gives us the average revenue. Okay, the revenue per rose bush. Every time we sell a rose bush, this is how much money goes into the cash register. Now you got to be careful. Revenue is not profit. Revenue is how much money comes in, is collected. Profit is how much money do you have after you've paid all your bills. You can have an enormous revenue, $4 million. Okay, but if it costs you $4,100,000 to produce those items, you're $100,000 in the hole. You're losing money. So realize that revenue can be a big number and you still not make much, if any, profit. The third thing we're going to do here is we're going to compute the average profit. Well, we're going to do that just the same as we've done the other two. And what we're going to have here is that our average profit at 2.5 is going to be equal to this 90 square root of 2.5 minus 100, the fourth root of 2.5 minus 80 over Q, Q being 2.5. Now, one of the things that I've not mentioned or pointed out here is when we have something, and I'm going right over to the far left side, so I got a little space here. If we have the fourth root of 2.5, how do you put that into your calculator? One way to do this is 2.5 to the 1/4 power, which should be 2.5 raised to parentheses 1 divided by 4. Be careful to put the parentheses around the exponent so that the entire exponent is applied as an exponent. All right. Next question says, okay, we've got our average profit. Our average profit is that function right there. And we're asked to compute the rate of change. Now, rate of change means a derivative because a rate of change is looking at how y is changing as x, or in this case, q, changes. So in order to get the rate of change, I'm going to need to take the average profit function, compute its derivative. Uh-oh. Okay. Well, the average profit function is there right at the top of the screen in orange. This is going to require a quotient rule. It's going to be f prime times g minus fg prime over whatever's in the denominator squared. I'm going to put that down first. It's called partial credit for right now. Keep in mind, Procter & Gamble does not pay on a partial credit basis. Either you did the job or you didn't. Either you keep your job or you're fired. Okay, no partial credit. Okay, so what's going to wind up happening in the numerators? We're going to have f prime g. To compute the derivative of f prime, that's the numerator, the first line up there at the top, over to the far right-hand side, I'm going to jot down what that looks like. This is going to be 90q to the 1/2. The second term can be rewritten as minus 100. The fourth root is going to be q to the 1/4 power. And then we have this minus 80. When I go to take the derivative of that, which is this f prime, I'm going to have 90 times the 1/2, which is going to give 45 q to the negative 1/2. Now, when I take the derivative of the next term, I'm going to have a minus 100 times a fourth. So that's going to be minus 25 q to the negative 3/4. That came from the 1/4 minus 1. The minus 80 is going to be a derivative of 0. So I'm just going to have these two times the denominator, which is q, minus, now what I'm going to have is a 90q to the 1/2. I'm going to put this in parentheses, minus 100q to the 1/4 minus 80 times the derivative of the denominator, which is just going to be 1. I can leave that as times 1, or I can just omit that. Now, one of the things that's very important to be aware of is when you have minus and then a bunch of stuff to follow, be sure that you include parentheses. If you don't, only that first term is going to get subtracted, and it doesn't distribute the negative over the entire thing. Okay, so we have the derivative. But we weren't asked to just compute the derivative. In this case, we want to find the average profit, the rate of change in the average profit when 250 roses are grown. So that means I want to take and evaluate this derivative of the average profit. And remember, with a derivative of the average profit, it gives us a rate of change. And I'm going to have 45 times 2.5 to the negative 1/2 minus 25 times 2.5 to the negative 3/4. That whole thing's going to be times q. Well, that's just 2.5 minus, be careful, include a parentheses or a bracket or something or other there. We're going to have 90 times 2.5 to the 1/2 minus 100 times 2.5 to the 1/4 minus 80, include the parentheses, all over 2.5 squared. Yeah, that looks like fun to plug in. I would encourage you to not try and plug that whole numerator in all as one piece, but to do it in small sections. Jot down what the result is for each section, then work through multiplying a couple of sections together minus the other sections. Once you get that, then divide it by 2.5 squared. Don't try and do this all in one gulp. Okay, so we've got actually here the derivative at 2.5. So the derivative, it'll let me write this, of the average cost is going to work out to be a total of 16.505. Now, 505, remember now, we're talking in terms of dollars. So I'm going to round this to 1651. What this means, and this is really important now, getting a number 1651 and not knowing what it's telling you about your business is a real problem because you're not in a position of being able to decide what should we do. Should we try to produce an extra 100 roses? I don't know. Okay. What this says is if we increase, okay, remember because this is a slope. Let me change this over to something or other that we can see. Okay. If we increase production from 250 roses to 350 roses, the profit will increase by 1651. Okay. Now, where did all that information come from? Okay, so hopefully you actually paused the video and tried working this out. You really need to practice some of these because when it comes quiz and test time, you're going to have to be able to plug numbers like this in and successfully get a value out of your calculator. You wind up with a negative 0.013, but since we're concerned about dollars and cents, we'll leave it like that. What does this mean? Well, first, remember it's a slope, so it's over 1. Whatever number you get out, it's over 1. This means that as the number of bottles, Q, changes by 1, the price, the cost, changes by negative $0.01. Is this a good thing or a bad thing? Well, what it's saying is that if we go from making 150 bottles to making 151 bottles, the cost to make the 151st bottle drops by a penny. It's called economy of scale. Oftentimes, up to a point, the more of something you make, the cheaper it is per unit. And you can see that happening here because if we go ahead and we make one extra bottle, the cost to make just that one extra bottle is 1 cent less than the other bottles. Okay. I'm sorry, the average cost. by making 151st bottle changes the average cost by 1 cent. The average cost goes down a penny. Well, that sounds like a pretty good deal. Hey, I hope this is helpful. Be sure to practice a bunch of these and be sure that you practice entering these rather lengthy arithmetic evaluations into your calculator.